This is a reading of the end of book 2 of an Aristotelian dialogue concerning the geocentric and heliocentric cosmologies, contra Galileo, which I am the author of and which you can find a copy of in the archive and Amazon links below. Again, I wrote this as a response to Galileo's dialogue concerning the two chief world systems, as a defense of the Aristotelian and Ptolemaic geocentric model of the cosmos, and is a refutation of the heliocentric model of the cosmos, as portrayed especially by Galileo, since his work was the most important of the scientific revolution. This part of the reading will conclude our strictly speaking cosmological arguments, our focus on whether or not the Earth is in motion or at rest, whether or not the Earth moves around the sun, or the sun and moon and stars move around the Earth. We left off with Galileo being given time to gather his thoughts to formulate a response to the Aristotelian disproof of even the possibility of the Earth's motion. Again, Aristotle's refutation of the heliocentric model, his refutation of the Earth's motion at all, was clearly stated in his On the Heavens, which I only expanded upon because he very briefly makes the argument, because the argument in form and content is sufficient and complete. So Galileo's response will be provided in this portion. And you will find that he largely admits the conclusion. And what I provide him is saying, I portray him as saying in this dialogue is taken verbatim from Galileo's dialogue concerning the two chief world systems. He knew that he had to approach this problem. He knew that he had to approach the Aristotelian critique of the heliocentric cosmos and of the Earth's motion. Now, Aristotle did not make his arguments from probability and improbability. The Aristotelian argument against the Earth's motion does not say that it is more probable that the Earth is stationary, and it is less probable that the Earth is in motion. No. The Aristotelian argument says it is impossible for the Earth to be in motion if the relevant celestial phenomena can be accounted for at all. And that if the Earth was in motion, and the Earth's motion was to account for the apparent motion of the sun, then the sun's motion north and south throughout the course of the year would be accompanied by a north and south variation of the risings and settings of the fixed stars, which does not occur. Therefore, the Earth cannot be in motion, since if the Earth were in motion and the Earth were to account for the sun's variation north and south throughout the seasons, and the sun wasn't itself moving north and south, but the Earth was turning so as to make the sun appear to move north and south, then that Earth's turning would result in the stars appearing to move north and south, as both the stars and the sun are hypothesized as motionless by Galileo. And any motion of either of them would have to be attributed to the motion of the Earth, which would result in the motion of both of them. You couldn't have a motion of the sun, an apparent motion of the sun, which the Earth's motion is to account for, without an equivalent and proportional motion of the fixed stars. Now, I will review this argument briefly. In order for the heliocentric theorist to set the Earth in motion, they make an analogy. In order to account for the apparent motion of the sun and moon and stars rising and setting that we observe daily, that we observe the sun and moon and stars rising and setting around the Earth as if in motion themselves. We don't observe ourselves to be in motion. In order to account for that, an analogy is provided whereby reference is made to the phenomena of being in a sailing ship, sailing along a coastline, whereby the motionless coastline has the apparent motion of moving against the motion of the ship. And the apparent motion of the coastline is accounted for by the ship's motion itself. That is an apparent motion whereby the coastline is really still and stationless, and the ship is in motion. But the coastline is made to seem to be in motion in the reverse direction as the sailing ship. In the same way, Galileo says that the apparent motion of risings and settings of the sun and moon and stars is accounted for by the motion of the Earth. The apparent motion of risings that we see of the sun, the moon, the fixed stars, and their settings is accounted for by the motion of the Earth rotating around itself. In the same way that the coastline, which a sailing ship sails along, appears to be moving in the reverse direction that the ship is moving. That is the approach of the heliocentric theorist that would have the Earth account for the apparent motion of risings and settings and everything else. Now, Aristotle, knowing this, Aristotle addressing the heliocentric theorists of his time, says that if the sun and fixed stars are hypothesized as motionless, which those who would set the Earth in motion, those who would theorize that the Earth is in motion, state plainly that the sun and fixed stars are themselves motionless, as if set along a coastline. And that any apparent motion of the sun and fixed stars has to be attributed to the motion of the Earth. Just as the motion of the coastline, the apparent motion of the coastline, is the result of and attributable to the actual motion of the Earth. Then also the apparent motion of the sun, slightly north and south to account for the seasons, throughout its course through the ecliptic or the zodiacal belt, would be accompanied by an equivalent and proportional apparent motion of the fixed stars north and south. Thus, if the sun is to account for if the sun's apparent motion north and south throughout its oblique course across the equator, if the sun's different position north and south across the equator is to be accounted for by the Earth itself turning, and that the sun varying position does not itself account for that phenomenon, but only the Earth's turning makes the sun seem to be as if the sun itself were moving north and south. Then, since the sun is hypothesized as motionless and the fixed stars are hypothesized as motionless, as both set along a fixed coastline, the result would be the whole coastline, for the motion in question has to be attributed to everything besides the Earth if the Earth's motion is to account for the motion of the celestial bodies, the apparent motion of them. Since the sun is merely stationed on a coastline, so to speak, and the fixed stars make up the coastline, then if the sun appears to change and vary in position north and south, so also should the fixed stars, as the motion in question, the apparent motion of the coastline, is the apparent motion of everything besides the sailing ship moving in the other direction. And any one thing on the coastline that is in motion that does not affect the fixed stars or anything else must be attributed not to the sailing of the ship, but to that thing that appears to move without affecting the rest of the coastline. And Galileo makes this clear that he is aware of the problem when he says, so the true method of investigating whether any motion can be attributed to the Earth, and if so, what it may be, is to observe whether bodies separated from the Earth exhibit some appearance of motion which belongs equally to them all. For a motion which is perceived only, for example, in the moon, and which does not affect Venus or Jupiter or the other stars, cannot in any way be the Earth's or anything but the moon's. And that is the sort of the problem that Aristotle addresses, that the motion that we observe the sun to appear to move with, moving more northern across the equator during the summer and more southern during the winter, should be attributed. If that isn't attributed to the motion of the sun itself, if that is attributed to the motion of the Earth, and the sun and the fixed stars are motionless, then that apparent motion should result also, should be accompanied by an apparent motion of all the fixed stars north and south. And those should be proportional and equivalent. Yet we do not observe any variation in the fixed stars and their risings and settings along northern and southern latitudes. Again, Aristotle's argument is that if the sun and fixed stars are hypothesized as motionless, just as the coastline and the analogy of the apparent motion of that being attributed to the actual motion of the sailing ship. Just, he says, if the sun and fixed stars are hypothesized as motionless, and any apparent motion of the sun and fixed stars has to be attributed to the motion of the Earth, then the apparent motion of the sun north and south would be accompanied by an equivalent and proportional apparent motion of the fixed stars north and south. And if there were to be an apparent motion of the sun, there should be an accompanying apparent motion of the fixed stars, as both are hypothesized as motionless, and any motion, apparent motion of either of them has to be attributed to both, has to be accompanied by both. You will find that Galileo largely concedes to the conclusion and then evades the force of the conclusion by various minutia, almost excuses of why we don't find that the fixed stars vary in the position along latitudes north and south, but throughout the year, the same fixed stars set and rise over the same parts of the earth, north and south. You will find that Galileo, largely in his own work, which I am providing much verbatim in order to show that Galileo really made these responses, that he admits the conclusion that we should see if the motion of the earth is to account for the relevant celestial phenomena and the sun's variation north and south. We should see the risings and settings of the fixed stars varying proportionally north and south. And the North Star should not remain unmoved. But we don't. And he admits that too. Then his maneuver is to account our lack of observation of what we should observe if the earth is to account for the movement of the celestial bodies. And those are fixed, especially the fixed stars in the sun. He says the reason why we don't find variation amongst the risings and settings of the fixed stars north and south is that either they are too distant from us and the change would be so minute that the observation will be difficult to make, and people aren't really aware of what the observation should be in order to focus on that specific problem. Then also that we would require more advanced technological equipment, that we would require better scientific instruments, which have not yet been developed. And he says that his idea is that in the future, better scientific instruments will be developed, which are more accurate and can observe this phenomena, which will, if the fixed stars can be observed to move north and south, in the same way that the sun appears to vary north and south, would prove that the earth is responsible for the motion of the celestial bodies. But that has not occurred. And the fixed stars simply haven't been observed to vary in their course north and south, but rise and set over the same latitudes. So you'll find that Galileo largely confirms the conclusion and practically confesses, because I'll remind you that this is set during the Inquisition. And yet this wasn't his trial. This was his exhibition of defending the Copernican theory before that could be suppressed. I will stop the video there and continue in the next one with the reading that will show Galileo's response to, again, Aristotle's disproof, not an argument from probability and improbability. Not that it is more probable that the earth is stationary and less probable that the earth is in motion, but that it is impossible for the earth's motion to account for the relevant celestial phenomena. And that if the earth were in motion and the motion of the sun and fixed stars were to be attributed to the earth, we should find something else. We should find a variation north and south of the risings and settings of the fixed stars, equivalent to and accompanying the sun's apparent motion north and south. If the situation is like that of the sailing ship, where the coastline has an apparent motion in the other direction than the sailing ship, and the apparent motion of the coastline is attributed to the motion of the ship, which is the case in that scenario. If that is a sort of way to account for the celestial phenomena of risings and settings, especially, then we should find that everything on the coastline appears to be moving in the other direction, as is the sailing ship. But we find that just something is moving on the coastline, that the sun is moving north and south. And the whole coastline isn't varying north and south. Again, if the Earth's motion is to account for the risings and settings of the fixed stars, and the fixed stars and sun and moon don't just rise and set around the Earth by their own motion, then the turning of the Earth, if the Earth is to turn north and south instead of east and west, to account for the sun's variation north and south, if the Earth has to turn north and south in order to account for the apparent variation of movement of the sun north and south, then the whole coastline would appear to move north and south, which we do not observe and does not happen. That is why Aristotle says, addressing the claim, if the sun and fixed stars are hypothesized as motionless, just as the coastline, and any apparent motion of the sun and fixed stars has to be attributed to the motion of the earth, because those are hypothesized as motionless. Then the apparent motion of the sun, north and south, would be accompanied by an equivalent and proportional apparent motion of the fixed stars, north and south. And both would appear to be in motion. And their motions would be proportional and equivalent. And Galileo concedes, admits the conclusion, and then says, well, the observation would be difficult to make because, for one, the stars are so much further than the planets, that the observation would be of a minute apparent motion and not something that is easy to observe. And that if we had more advanced scientific instruments, we'd be able to make those observations. And then the problem will be solved, but we haven't. That is the position that Galileo provides in his dialogue concerning the two chief world systems, as he knew that he had to address Aristotle's refutation, and that thousands of Aristotelians at the time were saying the earth cannot be moving around the sun, because if the earth's motion is to account for the apparent motion of the sun, then if the earth's motion is to account for the apparent motion of the sun, and any apparent motion of the sun is attributed to the earth, and any apparent motion of the fixed stars is attributed to the Earth because they are motionless, then if the Earth is to be in motion, the apparent motion should be of all the rest of the celestial bodies, just as everything on the coastline appears to be moving in the opposite direction as the sailing ship, unless something on the coastline is itself moving with a different motion, which, as Galileo said, if a motion is observed only in the moon and doesn't affect Jupiter or Mars, so the true method of investigating whether any motion can be attributed to the Earth, and if so, what that may be, is to observe whether bodies separated from the Earth exhibit some appearance of motion which belongs equally to all, as the whole coastline appears to move in the reverse direction as that of the ship, which is to account for the apparent motion of the moving coastline. For a motion which is perceived only, for example, in the moon, which does not affect Venus or Jupiter or the fixed stars, cannot in any way be the Earth's or anything but the moon's, if that motion is only perceived in the moon and doesn't affect everything else on the coastline, so to speak, then that motion cannot be attributed to the moving ship. It must be attributed to the thing that has a separate motion on the coastline that doesn't affect the rest of the, so to speak, coastline. And Galileo references the argument verbatim. He quotes Aristotle's argument, which again is about a paragraph, because that's how philosophy works. There should be two premises and a conclusion, and then you don't go on explaining with examples. So Aristotle's paragraph of about two premises and a conclusion is addressed verbatim by Galileo, who admits the conclusion and then evades the force of the conclusion by a qualification that what we should find and we don't find is because of the great distance of the stars, which would rather result in some minute and difficult to observe motion. That is why I provide so many references of Galileo. I provide so many footnotes, and I don't adjust his language, and I don't adjust his responses, and that his digressions are practically all verbatim in this work, and that they are not from my fancy, but that I am taking what he says and stating that verbatim as him saying that. And that his answers, yes and no, to Simplicius's questions are the answers that his position would have to respond with to Aristotle's arguments, which are also for a great part verbatim, or are parceled out into separate arguments that can be addressed to an answer rather than a string of continuous thought with himself. That Galileo has to answer to each part, that he has to affirm each premise, and then he has to admit that he agrees to the conclusion. But you can find all of these footnotes refer to the exact place where Galileo makes those statements. So I will stop this video and proceed with a different one to read the final portion of book 2 and to not make digressions. And this will serve as a review of the different sides of the problem. One side arguing for the Earth's motion, Galileo, and the one side disproving the Earth's motion, saying that the apparent motion of the risings and settings of the sun and moon and fixed stars is their own motion around the Earth and not the motion of a coastline moving in opposition to a sailing ship. Because the Earth would have to move with more than one motion to account for the celestial phenomena, would have to move with a second motion to account for the slight variation of the sun north and south that is oblique to the equatorial line. And that second motion of the Earth tilting or rotating or varying more north and south to account for the sun's oblique course through the zodiac. That is oblique, is not completely aligned with the equator. And that the fixed stars rise and set in line with the equator and the parallels according to that. That variation of the sun north and south on its path through the oblique ecliptic that strays north and south through its course through its path, which is oblique and not aligned with the equator, would have to result in a similar motion that we would observe amongst the fixed stars, that they would rise more north and south across lines of latitude. That is not observed, and that does not happen.